Okay, so I think I'm live, right? Okay. So what I'll do is, if anyone is watching this right now, just confirm me whether you are I mean, I am audible or not. I am audible and visible to you or not. Okay. Birthday blast this year with 50 to 9. Birthday blast, yeah. Okay, I'll just share it on Discord and then start with the video. Okay. And guys, please to write in the live chat, man. Like until unless I feel that yeah, there are people watching this, I can't start, right? Because today I am going to discuss all the four problems. I think for the first time after a long time, it's happening that I'm doing all the four problems. Okay, I have made it. Okay, so it's like for me, it's a good achievement because I thought that I was losing track. Okay, and I think like today's contest was not that difficult, like because Leetcode is presently getting the name that it's getting tougher day by day, right? But I think today's contest it was still okay, good, and even yesterday night was still better. Like I think this week they went on to like do something good with it. Okay, and it's nice to see that they are getting back. But I feel that like it was okay, like even if it was getting difficult, it was okay. Like it was at least challenging people that okay, you are getting more problems to solve. Because you know what, if the problems are easy now, so what happens is like you lose the motivation to solve them. Okay. Okay, so I won't be waiting much long for you people to join. Okay, I'll just start with the first problem. Find the largest almost missing integer. You're given an integer array nums and an integer k. An integer x is almost missing from nums if x appears in exactly one subarray of size k with nums. Return the largest almost missing integer from nums if no such integer exists. Return -1. A subarray is a contiguous subsequence, contiguous sequence of elements within an array. We know that, okay? So we have to find the largest almost missing. Now, what does this almost missing mean? We already know, okay? Like, but in case you're not much sure about it, what it meant about it. So let's say if you're having an array, okay, and what was it given in the question? That the array will be of size k, okay. So for size k, you can have various arrays. This is one of the size k array. This is the another size k array. This is another size k array, and this is another size k array. Okay, and for every specific array, you have to find out like which element is occurring. Okay, so if at any position you find out that one element is there, which was there in one sub array as well as the other sub array, so sorry, I can't take it. Okay, you have to like remove it. Now if you want a better optimized approach, then like we can come up with like various algorithms, like how to find it out, how to do it. It's basically like, if you notice at this, there is a pattern that it is either going to be the first element or the last element. Okay, and why is it so? It is because of the fact that only the first element, you can see that only the first element is there. I'll use a different color. Only the first element is there in red, but it is not in any other color. And only the last element is there in orange, but not in any other color. But if you consider for the blue, all the blues are in some other color or not. Okay. So this is one of the case that you have to do. like this is I'm telling you the most optimized approach. Okay, so it is like you can either consider the first element or the last element, but that element shouldn't be present in any other part of the array. Okay, it's like find the count of this element and then find the count of this element. So if any of them are having a count of 1, print that. And if none of them is having a count of 1, so print minus 1. And if both of them are having count of 1, so print whichever is the largest, because we were given to find the largest, right? See over here, 3 and 7, both are having a count of 1, so we printed 7. For this 3 and 7, 7 had count of 2, so we can't print that. But 3 had a count of 1, so we can print that. And for this 0, 0, this 0 is also having a count of 2, this 0 is also having a count of 2. So we can't print either of them. So we print minus 1. Okay. But the solution that I have done over here, that is basically to make you understand. Okay. This is not the solution that I propose you guys to do. What I'm doing is I'm checking for all the windows and I am finding its frequency of all the numbers, and like obviously I am using this vector int frequency internal. Okay, which means that internally, if in a specific sub array this element and this element are same, so should we increase the frequency by 2? Nope, because that is going to be considered as only one sub array, right? So it's like what you can do is you can have an internal frequency thing, so that if you find that the internal frequency is 1, then only you're going to increment the frequency of it. But if it is more than 1, that means it is a duplicate element, ignore it. Okay, so this is how you're going to make out the frequency thing. After that, if frequency of I is equal to 1, return I. Okay, clear? But now let's say the approach that I just now told you guys. Okay, it is going to be if nums of I, even I don't know whether this satisfies or not. Okay, but I'm just going for an experimental with you guys, because I know that is the basic thing that we have done. Okay, checking for every sub array. But since we have got the time now, initially it was given that 50-50. But if you have the time to later on upsolve a problem, try to optimize it as possible, as much as possible. Okay, so that is what I'm doing right now to make you guys understand the process. Like I have seen that many of you tell me that like I'm going through I'm doing this problem, but still I can't do the other problems, how to do it. So it's basically like whenever you're doing that problem, you're going for the most brute force approach. But after the contest, when you have the time to analyze it, just go through what is the best approach that you can have. Okay, because initially I was going for the big O n squared approach, but now I will decrease the memory space also, and I am also decreasing the time complexity. But I have to check whether this is a perfect solution or not. Okay, but according to the proposed algorithm that I just proposed right now, this should be a valid thing, right? So it means that if nums of I is equal to nums of 0, then make frequency of nums of 0 plus plus, right? And the same thing goes for this also, n minus 1. Okay, but remember one thing, this n minus 1 we are only going to consider if nums of sorry nums of n minus 1 is not equal to nums of 0, because otherwise we have already considered it earlier, right? So this is it. Great, good enough. Okay, so this should work, right? This should work. Let's do one thing, let's run the code. Hey, what the heck happened? line 7 character 16. If nums of I is equal to nums of 0, frequency of nums of 0 plus plus. What is wrong with it? This shouldn't be a problem. Can anyone who is watching this help me out with it? Why am I getting a runtime error? I guess now it feels that it was better not optimized. But I don't think there should be a runtime error, right? N is equal to nums of. Oh, okay. I was going for lesser than equal to. Okay, now it is finished. 6, 7, 3, minus 1, minus 1. Okay, so there is a minus 1 over here. Now see, this is a very important thing. Okay, why did the last one come as minus 1? Any idea? The last one came as minus 1 because this and this both were having a frequency of 2, right? And this is a subarray of 2, right? Now since this is a subarray of 2, so I was having the frequency as set as 2, right? I was going through all the elements. So that gave us a problem. Okay, which means that I won't be taking it as different frequencies, right? I will be taking it as same frequency only. So that is the part that there is a problem. Are you guys understanding it? Like, if you guys feel that this, like whatever I'm explaining right now, it is getting too boring, then I won't explain it. Okay. Come on, man. Just tell in the live chat. Do you think that it is getting boring? Because since many of you guys tell me that, like, bro, how do you solve problems, like, can you show me live? So that's the reason I'm doing this. Okay, otherwise I can go on to the next solution. If you guys like, if you guys want me to go to the next solution, you guys can write it in the live chat. Okay, I'll move on to the next question, sorry. Next position. I'm just basically optimizing the thing. Okay, nothing else. I've shown you how to code it down. Now when I start optimizing it, that is the part that I'm going to get troubled about. Okay, because it goes through various situations. I don't think, like, since the response to live chat is not that much, so I'll just skip the better, like going through the process. Okay, I won't do it. Okay, so it's good. We are okay to go with the second one. Longest palindromic subsequence after utmost k operations. You're given a string s and an integer k. In one operation, you can replace the character at any position with the next or the previous letter in the alphabet. Okay, wrapping around so that a is after z. For example, replacing a with the next letter will be b, but replacing a with the previous letter will be z, and z with the next letter will be a, but the previous letter will be y. Okay, so that means that there is a circular link. Okay, a subsequence is a non-empty string that can be derived from another string by deleting some or no characters without changing the order of the remaining characters. A palindrome, so we have to find a palindrome, which is going to be a subsequence, and we have to find the longest of it. Okay, now try to understand this. Okay, now I can tell you directly that this is not a greedy approach. Okay, you won't be okay with the greedy approach. A greedy approach would have worked if it was a sub array. Okay, but since it is not a sub array, so we have to go with the big O n squared. And if you look at the condition, it is 200. We can very much go with the big O n squared. Okay, like even the greedy approach was big O n squared only, but sorry, we are going to go with big O n cubed. Okay, in the DP, we are going to go with big O n cubed. Okay, but in the greedy algorithm, we could have gone for 200 into 200, but over here we go for 200 to the power 3. Now, if it was greedy, so this would be, instead of this being subsequence, if this was a sub array, we could have used greedy. How to use that? Okay, first let me tell you what the question is all about. Okay, you're given an array, you can take any subsequence, okay, and you can modify this any number of times. Either you go by making it plus one, okay, or you make it minus one, okay. Basically, which means that this subsequence that you took, this should be a palindrome. Okay, that means that this element and this element should be same, and this element and this element should be same. Okay, now since if you want to make these elements same, so you have to do some operations, right? You have to make them same. So what you can do is you can either from, let's say if this element is a and this is y, so what is the number of operations that you have to do? So you can make a minus 1, which makes it z, then make z minus 1, which makes it y. So in two operation you went to y. Okay, and in this case, if you are going for the reverse order, so you can make plus 1, it becomes z. Then again, when plus 1, it becomes a. Okay, clear? Now, since you have got the basic idea of the question, now let's say if it was a sub array. So what you could have done is you could have went to every specific position and kept that position as the middle element, and then put a pointer L over here and R over here. Okay, and check that how many operations you need to perform on L to make it equal to this element. Then go to the next position. Okay, R points now over here and L points over here. Then do this checking. You could have done that, and then you could have also done one other thing, that is the present two element you could have kept as middle, because this condition, it would be valid for odd numbered, odd length palindromes. But if you want even length palindrome, so you have to take this as L and this is R, do the same operation, this is L, this is R, do the same operation, and you go on doing it. Okay, until unless you find that you have done k operations already, so we can't do any more than that. This would have been the case if it was sub array instead of subsequence, right? Now, what if I told you that a little bit of modification can do it? Using a little bit of modification, we can do it. How? Let's say if the L and R, okay, we are not going to fix them. We are going to make it in a two-pointer manner. Like over here, we were going for a two-pointer manner, but now we are going to make it in a loop. Okay, that is one loop for L and the inner loop for R. Okay, works. And then we could have another loop ijk. Okay, I won't use k. I forgot what I used, by the way, the variable. Otherwise, like okay, no, yeah, this is one, right? size. Okay, so you can have a size. Okay, what is going to be the size of it? Clear? Now if I find that from L to R doing this number of operations, I'm getting a size of this, well and good enough. Actually, this is not the size, this is something else. I have just written it as size, but you don't have to consider that. Okay, you can go with size only. This is basically not the size, this is basically the number of operations, the size of operations. Okay, so that is what I have done. So this is a greedy algorithm. I mean, this is a DP algorithm, dynamic programming, where you're going to fix L comma R and then find what is the subsequence in that. How can you do it using greedy? Let's say if you know that till L comma R, you know what is the subsequence. Okay. So what is over here? L plus 1. Sorry, not plus 1. L minus 1 and R plus 1. So if you can do this, if you can make these two equal in K operations, or let's say in X operations, so whatever is the number of operations you needed to make this L comma R, you can add X to it and get the value, right? For L minus 1 comma R plus 1, right? If you want it for L comma R plus 1, you could have gone for it. If you want L minus 1 comma R, you could have gone for it, and this I already mentioned how to do it. Now you have to find a DP approach. Okay, how to do it? Let's say every element is a palindrome, right? What do I mean by that? If there is a single element, let's say A, that is a palindrome, right? It is a single elemented palindrome. B, it is a palindrome. F, it is a palindrome. C, it is a palindrome. D, it is a palindrome, right? So for every element that starts from I and ends at I, okay, starts from I and ends at I, and it takes, like, you can go for any number of operations. You can go for 0 operations also, it's a palindrome. You go for K operation, then also it's a palindrome. Okay, this is basically not size. Okay, I think I should have replaced it with operation for you to better understand it. Oh, okay. My mistake. This is size, but at the later point I go for J. That is the operation. Okay. Sorry. Submit a second question at 9:30. Okay, it's correct. Great, man. Like, it's about learning. Okay, you never have to focus on like how to. Why couldn't I do it within time? It happens. It happens with me also. So now I know that I have done all the operations till size is equal to 1, right? Now I have to do the operations for size equal to 2 till n, right? If I'm having a array of size n, so I have done them for every single element, and I know that for every single element it is going to be nothing but it is already a palindrome. Now I have to check for subarrays of length 2, not subarrays, subsequences within length 2. Okay, and you go on doing that. Then go for 3, then go on doing that, then go for 4, until n, that is till all the elements are taken, right? So first of all, I is equal to 0, I less than equal to n minus size, which means that how many I am going to take in the first go. Okay, L is equal to I, R is equal to I plus size minus 1. I just explained what L and R are. Okay, if you notice at this n minus size, okay, let's say initially I is equal to 0. Okay, so what is the value of L? L is equal to 0 and R is equal to nothing but size minus 1. That is size is 2, so that is 1, right? So you are going to check for the L equal to 0 and R equal to 0 case. Okay, well and good enough. Then you are going to have, let's say when I becomes 1, so in that case L is equal to 1 and r is equal to I plus size minus 1, that is 2. So that using this you can see that one thing, that all of them are going to have a size of 2, right? So for every element that is going to have a size of 2, I am checking it out for I, right? For all the possible subarrays, I mean possible bounds. Okay, so I find the L and R. Difference is equal to absolute of S of L minus R and S of L minus R, 26 minus absolute of S of L minus R, S of R. What do I mean by that? Let's say if you're having two characters, one is B and the other is, let's say, Y. And if you want to go from B to Y, you can either have Y minus B, right? How many steps it is going to take? B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. How many were there? 24, right? 24 steps. But what if we do the opposite thing? Y to Z, Y to B. That is Y, Z, A, B. Z, A, B. How many steps? 3. I think the previous was not 24. It will be 23, I guess. I made a wrong calculation, I guess. The previous will be 23 and this is 3, right? So you can notice one pattern, that if you are getting any one of it, the other one is going to be 26 minus that, because there are total 26 alphabets in the alphabet system, English alphabet system, English letter system, whatever you may call it. Okay. So I am going to take the absolute value of this, as well as take the 26 minus absolute value of this. Okay. Among this, whichever is the minimum, that is the number of operations that I have to perform. 23, yeah. That is the number of operations that I have to perform. Okay. I think even today is the chat lagging, because I have tried to fix it. No, I don't think that is lagging that much. So good. Now what I do, I am going to check for all the sizes. I mean all the operations, total number of operations that I have to do, because I know that I can do at most k operations, right? So if S of L is equal to S of R, yeah, which means the dp of LRJ, chat is slow again. No, chat shouldn't be slow, right? I don't think the chat should be slow. Okay, it is almost 4 seconds delayed, right? Let's do one thing. Let's check how much the chat is delayed. Okay. I will say hi, and the moment I receive that hi from the chat, I will just get how much the chat is delayed. Okay. No, this is not going to work. 3. Okay, let me just, yeah. The moment the ad gets over, I will just start with it. Okay. Complex systems don't need to be complicated. In fact, it's like I am seeing my own ads. How simple they can be. Introducing Surreal DB, the all-in-one. Hi. Okay, that's it. There's a 10 seconds delay, man. There's a 10 seconds delay. I get it. I don't know why this is happening. Like, I think there was a lot of frames delayed. Okay, I think that is the issue. Because when there is a lot of frames delayed, because what happens is, like, whenever I am streaming, okay, see over here you can see that there are 12 frames that has been dropped. Okay, so whenever I am streaming, what happens is that I am streaming, okay, It is greater, I get it. So I am streaming basically. But the fact that you guys are going to watch some ads in between the streams, and there are a lot of things. So that is the reason the chat gets delayed. Okay. Otherwise, like I think the latency is well and good enough. I will try to reduce the number of ads from the next time. But you know what? Like that is not going to give me a good revenue. Anyways, I'm not earning that much from YouTube. Okay, so it's okay. So 26 minus absolute of y minus b, right? Now this is the condition that I just explained you. L plus 1, r minus 1. Okay. Now see, we know that if S of L and S of R are equal, right? Which means that till L comma R, I knew this, okay? High on point, sorry about before. Okay, so I know that, let's say the previous element is S of L minus 1 and the next element is S of R plus 1, right? And let's say for this, you needed uh, X number of operations, okay? X number of operations. And you find that these two elements are same. So within this, you can concatenate this, right? Because that will also be a palindrome. If L comma R, I get the palindrome. So S of L minus 1 and S of R plus 1, if I put it at both the ends, then also it will be a palindrome, right? So in that exact X steps, I get the palindrome, right? So what is the present length of that palindrome? Don't think that if I'm telling about L comma R, that the length of that L comma R is R minus L plus 1. Because I am not going to be focused on the subarray. I am focusing on the subsequence. So I don't know what is this value. Okay, I don't know what is this value. But since this and this I know they are equal, so whatever this value is, I can add them and make it plus 2, right? The size. So you can see that I have made 2 plus this. Else, this is one of the conditions that both of them are same. Otherwise, what we have to do? Otherwise, I just explained you, we could have gone for L minus 1 or R plus 1, right? Over here, you can see that I am going for R minus 1 and L plus 1. That is because, not because the opposite thing is occurring, it is because like I have done some little bit of stuff on this, so that's the reason I am going for L plus 1 and R minus 1. Okay, because over here, this is, let's say if this was L, instead of L plus 1, if this was L, then this would have been L minus 1, right? So you have to consider this, what I just explained you using. But over here, since I am doing the opposite thing, so I am going for L plus 1, R minus 1. Okay. That is basically nothing but, let's say if this was S of L and this was S of R. So what should be in between? L plus 1, comma, R minus 1. Right? So that is what I am doing. So don't get confused with it that I am doing L minus 1 and R plus 1. But over here it is L plus 1, R minus 1. So don't get confused with it. This is one of the case. Now what we can do is, let's say we know what is the difference. What is the number of operations that we need to make this element as this. So we could have gone for this like, I need this number of operations. So I can include that in that case in j minus diff. That is, let's say we were having j number of operations to be done. Now I take away difference number of operations and I put it and I increase the size by 2. Okay, this is a valid case. We could have done this. But what if j minus diff is greater than equal to 0? Which means that k, okay, whatever the value of k was, if I'm doing that, if I'm doing making these two equal, I'm trying to make these two equal, I need more than k operations. Okay, that is j minus difference is greater than equal to 0. So in that case, I won't be making it equal only. I will keep it 0. Okay, I will just forget that there was something like that. Okay. Otherwise, what I can do is I can keep it as L plus 1 comma R or L comma R minus 1. What do I mean by that? That is, let's say if for L plus 1 comma R, I know what should be the value for this and I add a L over here. Okay. I am telling that it is going to be the same value. Now you may come up with a thing that if L plus 1 comma R was A B A, and that is a palindrome. Now if this is at C, so this is not a palindrome anymore, right? Again, I'm not taking the only sub array or the only subsequence. I am taking the maximum subsequence, which means that I can ignore this C. I can ignore this C. I can take this ABA only because that is the maximum. Even if I'm putting a C over here, then also the maximum subarray is, maximum length subarray is ABA. Okay, so that is the reason we are doing that. So similarly for L comma R minus 1 also, we can add the R and keep it as it is. Okay, so that is what we are doing. So whichever is the maximum, I am going to keep it as it is, and for the remaining I am going to make 2 plus that. Okay, and at the end I am going to return from 0 to n minus 1 the range and doing k operations. Okay, is the code clear? Whatever I have done and whatever I have just now explained you, is it clear? Ayana. Ayana. Now I think again it is like good enough. Now I think again it is like good enough. I'll use the timer. Now I think again it is like good enough. I'll use the timer. Now I think again it is like good enough. I'll use the timer. Now I think again it is like good enough. I'm starting the stopwatch. I'm starting the stopwatch. Yeah, now it is well and good enough. It is from like within that 5 seconds. It is like it gets used to it. Now the chat is again, I think, okay. Right? I'm able to see Mohit's comment in chat, then your live stream. I think your video is reaching us after 12 to 15 seconds later. So when you respond on comments, real time, but it reaches after. I get it. Like, see, the thing is, key, you can't get that instantaneous thing, okay? Because I am not having that, like, that amount of GPU, that amount of CPU speed. So I don't have that thing. Like, I am trying my best, but like, if I want to consider the quality of the stream as well as the time, the lagging of the chat, so I think that's okay. But I think if you refresh it, what you can do is like just go back by 5 seconds and then press on the live. So again, you will find that it the chat becomes a little bit better. Okay, let's move on to the next problem. Sum of k subarrays. Okay, by the way, I should have a poll started. How many problems did you guys do? 1, 2, 3, 4. Okay, sum of k subarrays with length at least m. You're given an integer array nums and two integers k and m. Return the maximum sum of k non-overlapping subarrays of nums where each subarray has a length of at least m. Very simple. Like, the question seems to be very simple. The solution isn't, right? Even the solution is simple. Okay, this is this much of solution, just 18 lines of code or 17 lines of code. Okay, because since we know that you're going to have a sum of k subarrays with length at least m, which means you have to divide the whole subarray into k parts where the length of every of them is at least m. Let's say if you are having a subarray and you can divide this into k parts, such that everyone has a length of at least m. Okay, you can do it, right? Actually, in this thing, I'll straight away go make you go with the code first, and try. You guys have to try to understand, because I think this was a very DP specific. I forgot what was the last question. No, the last question was a little bit of brute force, but these two problems, they were very DP specific. And after a long time, I am finding that Leetcode is coming back with its DP approach. Okay, that is the previous thing that they used to do, because DP was good for me. I was very much habituated with it. Okay, so I'm going to make nums of I plus is equal to nums of I minus 1. That is, I'm going to make it a prefix array. Why do I need it? Because let's say if I have an array and I want to find out what is the sum of elements in this sub array. How can I find it out? I can find out the sum of this elements, and then I can subtract from it the sum of this elements, right? Now if I want to just find out the sum of this elements, sorry, I'll use a different color, just this elements, or blue, yeah, just this elements, so it is going to take me big O n. Now let's say if I'm having one more subarray, then another subarray, then another subarray, then another subarray, and I have to find all of them. So it means that the number of subarrays, for every subarray I have to go for big O n, right? But why would I do it? Because if I can store the sum of all the elements from the beginning, so if I want to find this subarray, I can just subtract this red one minus green one, right? And I'm done with it. Right? So I can get that value easily. Now the thing is that, okay, we are done with it, right? Okay, so we have done the prefix thing. You guys have understood why we are doing that. I'm going to have a DP n plus 1, k plus 1. Why do I go for n plus 1, k plus 1? Because obviously I'm like, I can't, in every step I can go for like 1 based indexing and 0 based indexing. So I will just consider 0 based indexing, but I will do 1 based indexing on that. Okay, so that I can go on till lesser than equal to n and lesser than equal to k. Okay, because it is basically lesser than equal to n and lesser than equal to k only. The loops, they're going to be like that only. Okay, so one loop is going to be, okay, first of all, yeah, one more thing. I is equal to 0, I lesser than equal to n, dp of I of 0 is equal to 0. What does it mean? Anyone, any idea? What does it mean? Why is the chat so cold? Why is the chat so cold, man? Okay, no problem. We'll go on with it. What was I explaining? Yeah, since you know that if you're going to take for every I and take every length as 0, it is going to be 0 only, right? No, not the length, sorry. All elements of having 0 elements, and I is basically nothing but m, right? For m, because you know that you have to keep the values of I as at least m. So it has to be greater than equal to m, right? Now it is greater than equal to m, but a subarray can never exceed the value of all the numbers, right? That is, it can't have a length more than the length of the array itself. So it has to be lesser than equal to n. So basically you have to search for m till n. Okay, this is the size of every subarray that you have to search for. So that is what we are going to do. Over here you can see that I am going for I is equal to m to I is lesser than equal to m. But our main concern is not to search for all the subarrays initially. Our main concern is I have to make it k. Okay, I have to make it k because it is given that, sorry, yeah, I have to make k non-overlapping subarrays. So first of all, I have to make two non-overlapping subarrays. Then go for three non-overlapping. Then go for four non-overlapping. 5 till k. Okay. So this is the number of non-overlapping subarrays. So if I'm having none of the overlapping subarrays, like all of the subarrays are overlapping, so obviously I will have a 0, no matter whatever it is. But let's say I'm having one non-overlapping subarray. Okay. So what I can do is I can go on till I is equal to m to n and check that specific length. And what I'm going to do is the answer, I'm going to maximize it with I minus m, j minus I. Okay. What is I minus m? It means that whatever uh, is the value of my sum at this moment, I have to remove, sorry, whatever is the value, the length of my array, I have to remove m from that. Okay. Because this I minus m, if you notice the pattern with this I, initially I minus m. So I will just write the values for I minus m. So it is going to be nothing but initially it is going to be, since I is equal to m, so initially it's going to be 0, right? Then 1, then 2, then 3, and it will go on doing it till n minus m, yeah, n minus m. Okay, that is for all the sub arrays which is having that size of 1. Okay, so we go on doing it. So that is the values. Okay, so I can keep that value, and from there I can subtract nums of I minus m minus 1, which means that I need that sum, but I have to decrease, this is where the prefix comes. Okay, I have to decrease I minus m minus 1. Okay, so initially what is I minus m minus 1? It is minus 1, right? We can't do anything about that. So since it is minus 1, which means you have to take minus 1 elements. You can't take minus 1 elements. And if you're, even if you're taking minus 1 elements, it's equivalent to taking 0 elements, right? So that's the reason I find out that if this is less greater than equal to 0, then only I go for this value. Otherwise I'm okay with 0. Okay. So after that I go on doing it and I keep on checking the difference between them. Okay. Whichever is the maximum. Now I get the value of answer. Now I'm going to replace this dp of I of j with whatever was I minus 1 of j. What is I minus 1? That is, if the length was 1 lesser than that. So basically I am putting one extra element. That is the ith element. Okay, I'm putting the ith element into it. And if I find that I can put the ith element, okay, which means I have to find out what is the value of prefix till I minus 1. Okay, either I keep the dp of I minus 1 or I make nums of I minus 1. Okay, is it getting clear or like something is getting above your head? I know that the dp stuff, it is a little bit of hard to understand while explaining, but I'm trying to make it as clear as to you as possible. Okay, so I'm making this dp of I minus 1 of j and nums of I minus 1, and to this I am adding the answer. That is the previous thing that I got. Okay, हाँ या ना बोलो यार. like if you notice one thing, clearly, dp of I minus 1 j, this is like I'm taking like whether I am not going to consider that only. This means that I'm not going to consider that the ith element. Okay, but if I'm considering the ith element, so this nums of I minus 1 plus answer, okay, which is nums of I minus 1 plus dp of I minus m j minus 1, like you can find out a pattern over here. Okay, this is basically nothing but somewhat similar to 0 1 knapsack, just the fact that this is not 0 1. Okay, okay, this should be minus, I guess, no? That should be minus. If you still now don't understand what I'm explaining till now, this will make you understand. I'm removing m and 1. Okay, I'm removing 1 from the total number of subarrays that I have right now, and I'm removing m elements from it. So that means that I can put m elements from a new subarray right now. Okay, so what I'm doing is I'm going to put all the elements from I minus m minus 1 to I minus 1. Okay, is this clear? Like whatever we are doing, if you wanted me to go with normally the values, I could have done with it. Okay, I could have done directly this. Okay, but since you know that we have to consider all of them, so I have to go for answer is equal to maximum answer. But for now, for the time being, you can focus on this expression so that you understand what basically we are doing. This is very similar to the 0 1 knapsack. Okay, dp of I minus m j minus 1. That means I am taking out m elements and one subarray, because I know that one subarray has to have at least m elements. So I'm taking out m elements and one subarray, and I'm putting one subarray of size m from I minus 1, from I, not I minus 1, ith position. Now I think this is clear. I just explained everything in details. Okay, so let's check the vote. Okay, how can I check the vote? I have to pin it over, like if I want to check it. I don't know how to pin a vote. I think first of all I have to unpin this, or like that. If I unpin this, then can I pin this vote? No, I can't. So obviously undo. Okay, I have unpinned that. Now I have to pin this. Okay, so is it clear? Is it clear for you guys? Today I gave my first Leetcode, could only solve the first problem. It's okay. It's completely okay. Okay, so let's move on to the fourth problem. Lexicographically smallest generated string. Okay, I'll still go for the explanation. You're given two strings str1, str2 of length n and m respectively. A string word of length n plus m minus 1 is to be generated. N plus 1, n plus m minus 1, right? N plus m minus 1 is to be generated if str1 of I is equal to t, that means it's a true, which means that there will be a substring of word with size m starting at index I, okay, which should be equal to str2. And if it is f, that is it's false, that means it is not equal to str2 from that specific position. So what do I mean by that? You have a string. Let's say there is a true, true, false, 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 true, false, which means that you will be having another subarray. I mean another array. Okay, and if you start from this position and take the substring of length str2, it should be equal to str2 since it is true. Now for this also it is true, so which means that for this also it should hold. Okay, but since for this it is false, it means that for this position this shouldn't be holding. Okay, it shouldn't be holding. Now if you tell me to look at the pattern and understand like whether this is going to be a proper thing or not, I can directly say you that yeah, it can be, it may not be, you never know. Okay, so now what we have to do is we have to understand that how to do it. So let's first take some example. TF TF AB. Okay, TF TF AB. Okay, now the first position is TF. T. That means it's true. That means it has to be AB. Second, it is false. So it can't be AB. And it is starting with a B only. So we are okay with it, right? For this position, you find that there is again a AB. For this position, it is a false. Okay. And this position, you can write anything because I'm not like noticing anything about that, right? But no, you can't write anything that as you feel like. You have to keep it lexicographically the smallest. So over here, you have to write A, right? But what if, let's say, it was a AA. Instead of AB, the str2, it was AA. Okay, so over here it would have been AA, and again there is a true over here, so it would have been AA, right? But this was a false, but still this is a AA, so it is not possible, right? So I hope you're getting the pattern, right? There's a pattern over here. You have to understand that. So first of all, I'll just go with the code so that you will understand it better. Okay, I know that okay, this is so unnecessary. Sorry. This was I was just experimenting with it because I know that if I can't put A in it, so I have to put B in it to make it lexicographically still smaller. But that was not the right idea. Okay. See, I'm having the answer of size nm, that is n plus m minus 1 that I was given in the question. Now I am filling all of them with a dash, that is a fill in the blanks, blank space. Okay. I have a set. What does set means? Set means that whenever you are finding that there is a true, it means that the next str2 elements has to be str, right? So I can directly set those elements and say that sorry bro, this is fixed, I can't manipulate it anymore, I can't overwrite it anymore because this is fixed. Whenever I find that there is a true, I can fix the next m elements. Whenever there is a false, I can't fix anything, right? But since it is a true, it means that all of the next element has to be this only. If it was AB, then the next two elements has to be AB. If it was AA, the next two elements has to be AA. If it's a BB, the next two elements has to be BB. So I can set it out. So I am setting those elements. Okay. From j is equal to I to I plus m, I am setting those elements to str2 of j minus I. Okay. And I am putting this value of set. Why do I need it? Because I have to later on understand that which elements I had set and it can't be changed, and which element I have not changed, I have not set, but I put some values over there, but I can change it later on. Okay, so I have to understand that also very clearly. Now you find that if at any position you find that answer of j is not equal to str2 of j minus I, okay, you can return a null, which means that you have already set it earlier. But now when you are going to set it again, you find that there is a discrepancy. That is not the same element which was earlier set as A. Now if you set that element for the next true, now that becomes B. So you can't have it. What do I mean by that? Let's say there was A, B, C. Okay. I think it is taking a little bit of time to load. Okay, so you had ABC. Now the same thing. True, false, true, false. Okay. Clear? So for this true, I know I can set it as ABC, right? For the false, I can't set anything. Now again for true, when I'm going to set it, it becomes ABC. But this thing I have already set. The C I have already set. I can't overwrite it as A. Okay. So that is the part where the discrepancy occurs. So if I'm going to try to overwrite something, I can directly say, sorry bro, that's not possible. Return the empty array, empty string. Okay. Sorry, that is not possible. Okay, done with it. You're done with it. Now for all the blank spaces, since you have to make it lexicographically the smallest, you can fill all the blank spaces as with A. Okay, which is good enough. But now that doesn't make the feeling that it has to be A. It can be other than A also. Now since we have already dealt with the conditions where str of 1 was true, now we are going to deal with the str1 was if it was false. If it was false, I'm putting a flag, okay, which is initially true, that is 1. And I'm going to find what are the elements that are not set in that specific region. Okay. So what I'm going to do is I'm going to check for the next m elements, and if I find that all the elements are set, then there is a problem. I mean, sorry, all the elements are same. So that means that this should have been true, right? That means that this should have been true. But if none, like let's say if this is false, and even after doing this, that is putting the blank spaces as A, this is still a false. I don't have to do anything only, right? So I can clearly break out of it and make f is equal to 0. Because in this next case, we are only going to go to that if it is f is equal to 1. Otherwise, we don't go into it. Okay? So we can directly say f is equal to 0, break, I am okay with it. Like, it is still a false. Even after putting it as a, putting A in the blank spaces, it's still a false. So I'm okay with it. But if it is not so, okay, if it is not so, what I'm doing is I'm putting, like I'm checking if that specific position is not set of J, then in the not set, in this set, not set, I push back J. That is a position that was not saved. So I can have, in the not set, what I'm going to have is not set consists of all positions not set, that are not set rather, that are not set. Okay. Now if I find out that all of them are set, that is not set dot empty, which means that not set is empty, which means all of them are set. Now since all of them are set and I need to change something, so I can't do that. I can directly say, sorry bro, it's not possible for me. Done. Return it. But what if it is like, yeah, I can change some specific elements. So if I can change some specific elements that are not set, which one should I change? Let's say I can change a few elements, that is A. So if I want to make it still lexicographically smaller, so which one should I change? The last one, right? Because if I change any one of the previous ones, okay, if I change the last one, it is lexicographically smaller than the second last one, which is lexicographically smaller than the third last one. Okay, so you getting it? Like what we are doing. So we are going for not set consists of all positions that are not set. Okay. Actually, this was a mistake from my side. This should have been like you can go for A to Z also. It doesn't matter. But this should be, I guess. This should be S position plus 1. Okay. Which means that since it is not set, I find the last position that it is not set. Okay. Then I find a flag. This is just a flag, just to check like whether we can break out of it or not. Okay. Now what we are going to do is we are going to try to this. Let's say this was B. We have already done it, and this was B. Now I have to again change this. So obviously it means that I can't go back to A, right? I have B, so I have to make it C or D or E or F, and so on. Okay. So I can check for all the elements that are coming after it till Z and making it CH plus plus. If CH not is equal to str2, position of -1, answer is equal to position is equal to answer of position is equal to CH. So I can change that. The moment I change that, even it was true, like it was false, right? Let's say it was false, but it was deeming to be true. I again made it false. Okay, I again made it false, break it. But if you can't make it false, same thing. Sorry, bro, I can't do it. Return empty string. Okay, is the whole thing clear? हाँ या ना बोलो. चलो अब तो लग रहा है चैट प्रॉपर ही काम कर रहा है. Still don't know. No one did 3 or 4 problems. What was it like? I haven't checked my ranking though. I think like my ranking won't be that good because like the third and fourth was also not that hard. है ना? कितना होगा? Hardly वो होगा 2000 कुछ होगा शायद. Man, what the 474? Dude, अगर ये bugs नहीं रहता तो मेरा भाई भाई it is like 10 minute 5 that is I got a 30 minute of total bug issues because I was not coding seriously. So if it was not that, so I would have got it for 125. No, yeah, 125. And what is 125 ranking? Dude. ये तो ये क्या हो गया भाई? 125 मतलब होगा अच्छा खासा ही होगा. रैंकिंग 4 पे नहीं मिलेगा मुझे. आई थिंक 10 पे जाके मिल जाएगा. But 474 is a good rank, I guess. I thought that 3 and 4 was like it was done by a lot of people. Irony देखो, like when I do 2 or like somewhat like that problems, अच्छा 125, अच्छा फिर भी नहीं है इसमें. 15 करके देखते हैं. 14 करके देखते हैं. 14 पे मिल जाएगा शायद. 125 मतलब I could have got the thing like it's like I think it could have been well within 400 if there was no bug, or maybe within 300 also. I don't know, but 400 के तो अंदर होता, इतना मैं श्योर हूँ. हाँ 400 के अंदर होगा. 124 अगर 350 में आ रहा है तो 400 के अंदर होगा. डूड ये तो गलत हो गया भाई मेरे साथ. ये क्या होता है? LLM region is equal to LLM. Oh, okay. So I can check like okay. O3 mini did all 4 of the problems. Oh my god. O1 did all 4 of the problems. DeepSeek did all 4 of the problems. Taobao 1.5 did 3 of the problems. Pro did 2 of the problems. DeepSeek V3 2 of the problems. GPT-4 did 2 of the problems, and GPT-3 mini did 4 of the problems. Gemini did 2 of the problems. Gemini 2.0 Flash did 1 problem. Kimi couldn't do any problem. Taobao couldn't do any problem. Ernie did 1 problem. Quen did 2 problems. Zipu did 1 problem. सही है भाई, ये मुझे पता नहीं था LLM वाला भी दिखता है, ठीक है। अच्छा बाय द वे मैं भाई देख नहीं रहा, किसी ने कमेंट नहीं किया ना, चलो लेट्स डू वन थिंग, सिंस आई थिंक you guys are okay with it, let's move on to the best part of today's video, that is rating the problems. Okay, easy, कलर थोड़ा कलरिंग करते हैं, ठीक है। इजी, मीडियम, हार्ड, ठीक है, कलर्ड, दिखने में अच्छा लगता है। ए वॉज इजी, बी क्या था भूल गया मैं, अच्छा पैलिंड्रोमिक, बी और सी को मैं दोनों को मीडियम रखूंगा, ठीक है। आई डोंट केयर भाई उसने क्या रखा है, ठीक है, दोनों मीडियम था, बी और सी, बी और सी, और डी वॉज डिफिकल्ट, मतलब हार्ड, चलो ठीक है, कैन अंडरस्टैंड। हार्ड नहीं है, मतलब मीडियम ही है, बट थोड़ा मतलब दिमाग लगाना पड़ता है इस पे। आई थिंक इसका भी सेम ही होगा ना, इसका कैसा है, ये हार्ड है, ये मीडियम है, मीडियम है, easy. Okay, so I think like today's contest, the rating that Leetcode provided us with, it was well and good enough justified. Okay, it is like ABCD only. Okay, so yeah, that's it from my side. Thank you guys for joining. Okay, goodbye guys, goodbye.